All right, shall we start? Good afternoon. Thank you for being here after lunch. My name is Hooyberghs, and I'm going to talk to you about Semantic Kernel. Who in the room has played around with Semantic Kernel already? So some of you, okay, but most of you haven't. Cool, then I can start from the beginning. Very quickly, it's not really about me. I just want to mention that everything I show you today is already available on my GitHub repo. So if you go to my GitHub, there's a specific repository for today. The slides, which there aren't many of, are already on there, but also all the demos that I will show you. Throughout my whole GitHub, you will find many more projects that I'm going to show to you today. So if you need to look into those, you can find really everything up there. So I'm not going to show you anything that is not already up there. So you can basically already leave the room if you want, but let's just stay here. So the link is in the bottom, the QR code. I will also show it at the end of my presentation while you go out, so you can still scan it if you need it. With that said, very quickly, I'm from Belgium. I'm a software consultant. I do mostly architectural work for a consultancy firm. So I just like to play around with code. I'm still very technical. I'm a Microsoft MVP for Azure and developer technologies. And I'm just 40 years old, still having fun writing code. So that is what I love to do. As I said, there's not many slides because I just want to show you what Semantic Kernel is all about, what it can offer you, and what you can do with it. So it's going to be demos for the almost entire hour, so I'll hope you'll enjoy that. To start off, I'm going to show you this slide. I'm starting to feel like a grandpa, 40 years old, but still when AI came, or Gen AI came a couple of years ago, I was the guy that stood on the sidelines going, it's a hype. We're not really needing this. But when I looked at it a little bit more, I think it's still a hype, but there's also a lot of things that we can do as developers using it, and using it in pretty cool ways. So I guess it's going to stay, Gen AI, and we can really leverage it to do awesome things in not only helping us to code, but also using it inside of our applications to do all kinds of fun stuff. So that's the only slides I have. Let's go to Visual Studio. So I've prepared a couple of demos just to show you what Semantic Kernel is all about. So Semantic Kernel is a package, it's a NuGet package. It is available in .NET for C#, but it also has support for other languages. You can also do Java and use Semantic Kernel, and there's some more languages that have support for it. Semantic Kernel is a package from Microsoft, and it can help you to leverage existing Gen AI large language models inside of your applications. So it just provides you with classes and methods on top of those classes that you can use to use those large language models to your advantage. So very simply, you just install the Microsoft.Semantic Kernel package, and here is a small console application that is using OpenAI. It's using Azure OpenAI. So if you're using Azure, you can create a workspace on Azure, an AI workspace, or as they call it these days, an AI Foundry resource workspace. There you can deploy all kinds of models. I have deployed a GPT-4o, a GPT-5 model, and then you can use those models because you will get an endpoint and a key to basically point towards those models. So I've deployed it before. I've put that endpoint and key as an environment variable, and now I can start using Semantic Kernel. Semantic Kernel provides to you a class called kernel, and it works a little bit like the things in .NET that we're used to. We can create applications using an application builder. We can create web applications using a web application builder. So for Semantic Kernel, we can create a kernel using a kernel builder. It's the exact same concept. Now, you have a couple of extension methods available on this kernel builder that allow you to connect to an existing large language model. The cool thing about Semantic Kernel is that it builds an abstraction layer on top of that, so you don't really need to know the APIs for OpenAI or Azure OpenAI or some other vendors. You just use Semantic Kernel, and Semantic Kernel will abstract that away from you, and it will basically do all that hard work for you. So just install an additional package if you need something that is not integrated by default to connect to the large language model that you need. Then when you're ready with configuration, you can build your kernel. Now you have your kernel available, and you can get a service through dependency injection called the chat completion service. So the chat completion service is a built-in functionality that allows you or your users, of course, to do a chat, an interactive chat, using that large language model. So what I've done here is a very simple while-true loop. The most code that you see here is just for coloring input and output. The only important things here is basically calling the chat completion service instance and using the getStream chat message content async method. So what I'm sending is the request, which is the question from the user, and I'm providing it with the kernel, the semantic kernel that does all the abstractions for you. And you will get a streaming result. A streaming result, just like when you use ChatGPT, you will see the response of the large language model coming in chunks. You will see it being built in real time. You will get the same thing here. That is why we use an asynchronous await for each, an asynchronous enumerable, because we will keep getting the content while the large language model is outputting it to us. So if I run this, shouldn't really be a surprise that we basically created in only these few lines of code a chat with a large language model. So I can ask, for example, is Carlsberg really the best beer? And then it will answer this question. That's it, very simple. Integrating an LLM in your software is just as easy as these few lines. So it says it's probably the best beer, blah, blah, blah. I can, for example, ask, where is it from? And then the large language model replies with your question, where this from is a bit unclear. Could you kindly provide more context? So this is very important for you to know that every question we ask is a question on its own. The large language model itself does not have any context. It does not have any state. So in order for a real conversation, in order for you to have a real conversation with a large language model, you need to send the whole history every time because it's stateless. So you really need to provide that. And Semantic Kernel has that built in for you. So you can use that built-in feature. So that's the second project here. So what you need to do is you need to keep an object called chat history. And chat history is basically an array that has all of your chat messages, both from the user and the large language model itself. So when the user asks a question, you can add that message to the history as a user message, because this is a message, a question from a user. Then when the large language model replies, you basically await for each, for all the chunks to come in until that is finished. When the entire answer is received, you can keep that as a full message and then add it as an assistant message. So the large language model is called the assistant and your user is called the user. Now, if you keep that history running, you don't send the question from the user itself, but just the entire history object with that request. And then, of course, your large language model will have more context on your conversation, and it will be able to answer those follow-up questions. So, is Carlsberg the best beer? I'm going to get somewhat the same answer. Totally different answer this time. Where is it from? And it will tell you it's from Denmark and it was founded in Copenhagen. So now it knows that context because you've sent the entire history. Again, very simple concept. Of course, this can already be tricky when you allow your user to use your chat for an infinite amount of time. Your history builds and builds and builds, and the larger your history gets, the more time it's going to take for your large language model to interpret that. And it's also going to cost you a lot more tokens, thus a lot more money. So you need to be aware of that so that you don't allow your user to keep running a chat forever. Also, the large language model will become more unstable if you provide it with too much context, because then it becomes very hard to make sense of that, and then it can start to hallucinate a lot quicker. So something to think about. Maybe you can send only the last X amount of chats, or you make a different large language model agent that basically does a summary, and you only send the summary, for example. So the options there are for you to explore. The next thing, there's user messages and there's assistant messages, but there's also system messages. System message is the third kind of message that you could put in your history, and system messages are not for your user. Your user will never see them. It's for your large language model. So you can provide them to your large language model to make it act in a very specific way. If you want to have a specific persona, for example, in this case, you should answer as a 10-year-old child, you can provide that as a system message, and then you can start chatting with your user, and then the responses from the large language model should adhere to these rules to best effort, of course. So let's try that. So if I ask, what is Denmark? I'll get, oh, Denmark is a country, exclamation mark. So it sounds a little bit more as if a child was answering this question, and it doesn't really sound like it's an adult. I tried something fun here. With each question I ask in the chat history, I'm going to drop the age of the large language model with 2 years. So I can ask, what is Europe? As a follow-up question. Oh, blah, blah, Europe, and then I'm 8, by the way. So what is Earth? I'm just making this thing up, making things up. I'm 6 years old. Animals, vraagteken, question mark. So it's getting younger and younger, and you can see it's quite impressive for a 4-year-old still, but you can see it's getting a little bit different in the way it answers. So let's go all the way to 0. What are plants? I'm 2. Are there aliens? So guguba. So we don't get any relevant information anymore because now the large language model is 0. So you can keep adding these system messages to your chat history, changing the way the large language model needs to react, basically. So these system messages can really help you to prompt engineer the way your large language model needs to answer your customers. If you are writing an application for children, this is the way to go. Just make the questions good for a 10-year-old or whatever. Do you want to just have a fun little thing, make it answer fun? Do you have an executive kind of copilot that you're trying to write, make it answer in a professional way, basically, by just adding these system messages. So what I'm doing here is not the best because I'm adding a system message on top of the already existing system messages. So if you go look here, I'm just decreasing the age with 2 years and I'm just adding a new system message to the whole history. Of course, it should have been a little bit more performant if I just removed the earlier system messages so that the large language model doesn't get confused with all of those system messages sitting in the history. All right. Now, this is already all fun and games, good fun and games, but this thing is what actually caught my attention, and that's plugins and functions. So if I run this example and I ask for real-time information, then we have a problem because a large language model isn't trained on real-time information, it's trained on historic data. And that model is trained and it's fixed, and it doesn't know about real-time things that are happening. So if I'm asking something like, what is the current time? It says I currently don't have access to real-time information, including the current time. And this is an unfortunate answer because every time I tried this before doing this talk, it actually was kind of passive-aggressive with me, and it told me, just look around, maybe there's a clock somewhere, which I found funny, but now it doesn't do that, and there's a clock right there. So I can't ask for the current time because it doesn't know. It's, of course, not in the model because that is real-time information. Now, Semantic Kernel allows you to create plugins, and plugins are, in this case, classes. Some large language model vendors call it tools. In Semantic Kernel, we call it plugins and functions. Inside of a plugin, you can bundle a number of functions that are able to get real-time data for you. And these are very simple. I just created a function or a method in C# called getTime that gets the current system time of day, and getDate, which gets the current date only. The thing you need to do is you need to add the attributes to tell Semantic Kernel that it's indeed a kernel function, so it's part of the plugin. It's part of something that we want to add to the large language model as real-time information, and you give it a description. The description needs to help the large language model understand what the function actually does. You can add descriptions to the function itself. You can add descriptions to all of the parameters if there are any parameters. And you can add descriptions to the return type to fully describe what your function actually does, what it needs, and what it returns. If you did that, Semantic Kernel will transform this into the syntax that is necessary for the large language model to understand that these are tools, these are functions, and that differs for any model that you're using. So OpenAI has a very specific way of doing that. Ollama has a different way of doing that. It depends on the platform and the models that you are using. Some models have support for tools, some models don't have support for tools. So this is also something that you need to be aware of. And again, Semantic Kernel will just use reflection from .NET to build this into probably a JSON object that it will send with your request depending on the model that you're using, and you don't need to worry about that. The only thing you need to worry about is writing the code. So if I enable this plugin by going to my program CS and using my kernel builders.plugins to add from type general plugin, which is that class that contains those methods, it's now part of your kernel, and actually the only thing you need to add is the tool call behavior called auto invoke kernel functions. And this one is important because what is going to happen, let me first show you what is happening. So if I start this and I'll ask again for the time, what is the current time? It will tell you the current time is 13:57, which is almost, we were just 3 seconds behind. So 13:57, that's the real-time current time, and this is what the LLM actually returned. If I put a breakpoint in this method, and I go back and I ask the same question again, what is the current time now? We will hit this breakpoint, and we will get the return from that method. So it looks like the large language model is calling into our code, getting that information that it needs, and then replying to the user with that real-time information. That is, of course, not entirely correct because the large language model doesn't have access to our code. The thing that we do is we send the initial question, and with that question as a system message, automatically we'll send which functions or tools are available. And then the large language model will look at the question, and if the question needs any of those functions, it will reply to us. And with us, I mean us developers. I can't answer this question from the user because I need this information. So we, as a developer, need to fetch that information and then send a second request to the large language model with that information so that it can actually formulate a response with that information and then send it back to us. So we're basically going back and forth with the large language model, providing the correct information, and then when everything is finished, it will actually send that message to the user. So this is when you want to do that manually. With Semantic Kernel will do that for you. And that is the meaning of the auto-invoke kernel functions. So we don't need to worry about that. It will do that for us in the background, going back and forth. And then when all of the information is available, it will actually send us a nicely proposed way of telling the user or answering his question with the correct real-time data. I've written a little debug function here that will show you the whole history. And if I run it again, and I'll ask, for example, what time is it and what day of the week are we? Need to remove my breakpoint, of course. Now it tells us the current time is 2 p.m. and the day is Friday, September 12th. And this is the whole chat history that you see here. So first we have a user message. What time is it? Then we have an assistant message that also tells that there are two functions available, the general plugin -get time and the general plugin -get date. It's basically the assistant telling us that we need to call those two functions because the user is asking information that can be retrieved from those two functions. We call those functions with the tool. The tool has a result from those functions. We send it back to the large language model, and then the assistant gets this information, ties it all together, and returns the current time is 2 p.m. and the day is Friday. So we go back and forth a couple of times, again, automatically, thanks to Semantic Kernel. Something that I'm not showing you here is that you can also have arguments in your functions. So if you describe well enough what the arguments are, the large language model is also smart enough. I'll be using these a lot. It's smart enough to basically get the correct information as those arguments. So for example, if you want to get the weather in a specific city, and you have an API call available to use some external service to get that information for you, and the user asks for the weather in Copenhagen, then the large language model will tell you to call that function with argument Copenhagen. So that's very, very cool, very impressive, and very handy. So that is tools and functions. Then along the way, the Semantic Kernel team has added a different way of using these chat completion services. So chat completion service was something that we used about a year ago. Today, they're trying to push the concept of agents. So now we're going to build an agent, and an agent is something that can do things for us and that can get information for us for a very specific use case. So with an agent, instead of adding system messages to your history, you can also give it instructions. So this agent, for example, is an agent that knows about the current date and time. And the instructions that I'm sending with it is that it should only reply on questions related to the current date and time. So if I run this, which is the exact same functional behavior, I have the same kind of functions available. I have the same automatic invocation of kernel functions available, and I have the same while loop, but now I'm not using the chat completion service, I'm using the chat completion agent, which is quite similar in concept. But if I run this, and I ask, where is the Eiffel Tower located? It will tell the user it can only assist with questions regarding the current date and time. So if you're building this kind of copilot or agent for your application, by using the concept of an agent, you can really limit the way the large language model should answer your user, so that they can't use it for whatever they want. They will only use it for whatever you want them to be able to use it for, thanks to those instructions. Again, if you're using the chat completion service, you can just add that as a system message. It will have the same result, but now from a developer's perspective, it looks conceptually more correct because you have an agent that can do specific information. By the way, I told you before, because agents are mostly AIs that use GenAI to also do things, that is actually very easy to do, because I'm now showing you a plugin that retrieves data. It retrieves the current date and time, but nothing holds you back in doing whatever you want in this code. You can actually execute functions in your application, in your business logic that also actually do something. So you can build agents that actually perform actions. I will show you later, but I have built agents in my home that are able to unlock my car and stuff like that, and it will actually unlock my car when I ask it that question, which is pretty cool. Because this is just .NET. You can call whatever API remotely and do all the fun stuff that you want to do. So I also have an example here that shows to you not using Azure OpenAI, but using Ollama. The concept is exactly the same. I just have a different extension method on my kernel builder. I'm not going to add the configuration data for Azure OpenAI. I'm going to add configuration data for Ollama. What is Ollama? Ollama is an open source tool that runs large language models on your local machine. So I've installed Ollama as the tool. I've downloaded the Llama 3.2 with 3 billion parameters locally, and I can run the same kind of application locally on my machine, hopefully. So let's try. It does need some memory, and this is a rather small machine, so let's see if it works. So what time is it? It's going to take a little bit longer because, again, the model is running on my local machine, and hopefully it will give me an answer. The current time is 2:06 p.m., which is correct. And this runs completely local, so no remote access needed. So you can still use Semantic Kernel with large language models that you basically host yourself, and you don't need to rely on external services like Azure or OpenAI or whatever you want. So again, thanks to Semantic Kernel building that layer of abstraction for you, you don't need to worry about how to communicate with these models. Semantic Kernel will do that for you. And then we come to the final things of these demos that I want to show you, and that is MCP. Who has heard about MCP? Also a couple of you. So MCP is the Model Context Protocol. It's things go very quickly in the Gen AI space. So a lot of tools are being built, a lot of concepts are being built. MCP is one of those. Is it handy for your case? I don't know. You have to think about that yourself. But the concept of MCP is that when you have an application or a platform or a service online available, you can make it so that people, developers like us, can easily integrate with your platform when they use large language models. And that is what MCP actually is. So for example, GitHub has an MCP server that allows you to use tools that they have written on top of GitHub. So if I look at this code, I'm doing the same things. In this case, I'm going back to using Azure OpenAI. I'm creating a semantic kernel builder. I'm using GPT-4 in this case. I'm building the kernel, but then I'm adding this as a little step. I'm creating an MCP client for GitHub. And this is a bit weird, but this one is running locally using NPX from NPM. So it's basically downloading the GitHub MCP package locally, and it's running that package locally. And then this package will give me a list of tools, which are basically those functions that I've shown you before. Get time, get date, those are tools. So GitHub has a list of tools, and then I can use those tools in my agent. So for example, this is a GitHub agent, and it's an agent that helps to get information from public GitHub repositories, and the instructions are that it should only provide information about those public GitHub repositories. I'm not going to type it manually, I've just hard-coded it this time, and this one is going to summarize the last 5 commits of this specific repository. So if I ask it that question, the first thing that it will do is get those tools from GitHub, and this is a list of all the available tools, so that's a lot of functions, and then this description of those functions. And then by asking it to get me the 5 latest commits, hopefully it works, it will actually do that, And it will automatically do that by calling one of the applicable functions from that top list of functions. So again, you have a platform that's publicly available. You want developers to integrate with your platform. You provide an MCP server. That MCP server provides a list of tools that they can use. In many cases, they're going to need an API key in order to actually do that, so that you can log your developer customers that they're actually using your platform, and then they can integrate that into their implementation that uses a large language model. So in this case, I'm using the GitHub MCP server to get that information from their platform. Another example that does the exact same thing, but for Google Maps. So Google Maps also has an MCP server, which I'm using also through NPX. It has a different collection of functions, and I'm asking it to help me get directions between Willebroek in Belgium, that's where I live, to Copenhagen in Denmark. And then it should use Google Maps to actually allow me to get directions for that specific route. So these are all the functions or tools that are provided by Google Maps. It will tell me that's a 900 kilometer drive, around 11 hours. And then it says how I need to drive to get here, which seems pretty easy. Just go through Germany all the way north. Lübeck, there's a nice theme park in Lübeck. I'm a theme park enthusiast, so that's why I know. So yeah, pretty cool. Now, of course, you as a developer can also build these MCP servers yourself. And that's what I did in the following demo. I'm just going to use this one. So I've created an MCP server. This is just an ASP.NET application. It's a web application builder that I'm using to build an ASP.NET web application. It has a very similar concept of tooling, because this is not part of Semantic Kernel. This is part of the MCP protocol that Semantic Kernel integrates with, but because this is only the server-side part of that, it's actually using a different NuGet package, which is called the Model Context Protocol.asp.NET Core, so MCP ASP.NET Core. So it has a very similar idea where you create a class with a couple of functions, you put attributes on top, you describe what these functions do, and then in your program.cs, you just add an MCP server to your dependency injection. You use the HTTP transport protocol because you want it to be available through HTTP. And you add these tools with the with-tools extension method. Again, this will be automatically translated into endpoints that are valid for the MCP protocol. So you don't have to build them. This extension method will build them for you. And then you map those MCP endpoints on top of your web application, and you just run your web application. So if I run this, it's running. And then you can look at the client, which is very similar to what I've shown you earlier. So I'm again using Semantic Kernel here. I'm creating the MCP client, but this time I'm not using NPX or Docker. I'm using the server-side events client transport protocol, because now I want to connect to an HTTP endpoint. I'm just providing it that local host with the correct port, which, by the way, I think I've changed. So very quickly, oh no, 55215. No, okay, it's fine. So I'm going to run this MCP client. It gets those two functions because it lists all of the tools, and then it asks for the current date and time, which will now work. But again, those functions live remotely, and I'm using them remotely through the MCP protocol, which I think is a pretty cool idea. So we have around 20 minutes remaining, because I also want to show you some things that I've been playing around with myself. So first, I need to give you a little bit of context about this one. I have been doing quantum computing for the past 6 years, just as a hobby that got a little bit out of hand. I also do a lot of presentations on quantum computing. And last week, I did a summer lab. So I did a workshop, a 2-day workshop on how to write quantum code. I'm not going to bore you with quantum itself, but I decided as a hands-on workshop, I wanted to have the people that attended it to solve challenges. And when they solve those challenges, they're basically learning how to program Q#. So in this platform, there's, for example, challenges. Those challenges will ask them to build in code a very specific circuit for quantum computers, depending on the question. And when they provide a solution, like this, let's do return 5, which is not correct. And when you submit the solution, it will tell them they failed. Because internally I'm doing a couple of unit tests to see if what they wrote was actually correct, and if it's not correct, I can tell them very specifically what they did not achieve. But I decided to help them with a specific copilot for this thing. So I'm just going to do clear chat to start over from scratch. And this is, for me, where the power of Semantic Kernel really shines. Because because I had 60 participants and I was all alone for this workshop, so I didn't want these 60 participants to always call me. If they had a question, they could ask the Copilot. I've decided to use the Copilot term because Microsoft always uses the Copilot term, but you can call it whatever you want. So I've used Semantic Kernel with an agent that I've described specifically that it only can be used for this purpose, for this challenge. And thanks to those tools and functions, I gave it more context about what is actually happening here. So I can ask questions like, can you help me with, learn to type, with challenge A2? And then it will tell you, all right, Johnny, that's because I'm logged in as Johnny, so it knows who I am. Here's a little hint to get you going for challenge A2. It will tell me that I need to understand the difference between the I and the X gate for quantum computers, and so on. But I can also ask it, what did I do wrong? Because I already submitted a solution that is wrong, and it will tell me, sure, I can see the issue. Right now, your code is not actually using the given unitary operation. You're basically returning the integer 5, which doesn't tell you anything about the gates that were supplied I or X. So it knows about the things that I did wrong, because I basically gave it access to that. So it's just what I've already shown you. If you look at the code, and I go find where the actual where did I put it? Here, Copilots. Copilot functions. So this is that class with those kernel functions where you can see like more real-life example of those functions. Like, for example, get challenge information. And it has a lot more context here. It gets more information about a specific challenge with a specific name. The description of the return type is the name, the title, the level, the full description, and the signature of the operation that needs to be written to complete the challenge. And then the actual attribute here. So I'm sorry, where is it? Here, the string challenge name, which is an argument of that function. It's the name of the challenge to get the information for, and it can be 0, A1, A2, A3, up until D1, D2, D3. So I'm providing as much information as I can about that function, so that when the user asks a question, that the large language model knows that it needs to call this function with the correct argument. There's another function more down, get my current leaderboard position. So if they ask something about the leaderboard, then they will get more information about where they are on the leaderboard. Get my latest proposal. This is the one that when the user asks, what did I do wrong? It will call this function to get what the user submitted lastly and gets the information from that. So again, just writing a couple of functions like this allows that large language model to actually get the correct information and answer that user's questions more clearly, which I think is pretty amazing, and it's pretty simple to implement for something like this. So I've created a Copilot with not a lot of effort by just using an existing large language model and provide it with just enough context so that the user can only use it for that purpose. Another thing that I want to show you that I did with Semantic Kernel is this one. So over the past few years, I've been automating everything in my home without Home Assistant. Not because I don't like Home Assistant, just because I just wanted to do something fun and crazy. So I decided to have everything that is related to my electricity usage. I found the API for that from the public company that provides electricity, so I can call that, get all of the information about electricity usage. My solar panels, I've managed to integrate with my inverter, which uses a specific protocol, which works fine. My car is an electric car, so it also has an API, so I can do almost everything with my car. My heating doesn't have an API, but I found the Android app, and I listened to the network traffic on the Android app. I decoded that traffic from providing a fake SSL certificate, and now I know where the endpoints are, so I'm basically calling that. My sauna I've built myself, so I can integrate with whatever I want from my sauna, and then I have a smart lock on my front door so I can get all of that information. And I decided to use Semantic Kernel to be able to create a copilot for all of this. So if I ask a question like, where is my car located? It should get that information. It's located in Brussels, Zaventem, which is the national airport in Belgium, because my car is parked there, because I came by airplane, not the 900 kilometers to talk for 1 hour. So the cool thing about this, again, Semantic Kernel has that real-time context, because I've provided tools to get that real-time context. But we have a little issue here. And that issue is, all of the things you see here, that's a lot of information. That is a lot of tools. So if you look at the code, by the way, again, all of this is on my GitHub. If you look at the tools, now I need to think where they are. I think here, Copilot. Yes, so I've created multiple classes. These are all the functions related to my car. So get car location, is car locked, is the car charging, get the range, get the battery health, make it do a fart, because it can do that. Preheat the car, lock the car, unlock the car, and so on. But then there's general functions. There's functions for my heating, there's function for my power, for my sauna, for solar. Again, that's a lot of functions. So with every question that a user is asking, you need to send all of that information with the request, using a lot of tokens, making it very hard for the LLM to know which function do I need to call. If you send hundreds of functions where it can choose from, that can become quite unstable. And that is what I want to show you in the final demo. Because what Semantic Kernel also allows you to do is do agent orchestration. So that's this one. I'm going to try to run it locally, but the internet connection is not the best here, so we'll see if it works. And otherwise, I've deployed it to Azure very quickly, so we can also use that. So this is what I call my Copilot, and it's the same one as before, but now it's using different agents to get to the correct question. So if I ask the same question, where is my car located? I haven't built in the speech to text here, so before I did it with speech to text, but that's not yet here. It will take a little bit longer. Not too long, I hope. It will tell me the car is located in Brussels, Zaventem, and it will tell here which agent actually answered the question for me. If I ask a different kind of question, like, what is the current temperature in my sauna? The answer came from the My Sauna agent and not from the car agent. So now it's smart enough to use the correct agent, so I'm using multiple agents, and this is quite interesting, because now I can create multiple agents where each agent has a very specific knowledge. And if my question gets redirected to a very specific agent, I only need to provide the functions and the tools that that agent needs. It's quite complicated, and it needs a lot of fine-tuning, but the idea is the following. inside of a semantic kernel, I need to think where it is again, the Copilot helper. So here is the same thing that you've seen before, but integrated into an application. So I'm using the same kernel builder, but here is also what we call an orchestration manager and an group chat orchestrator. I'm sorry. So an orchestration manager allows you to build your own orchestration tool that will help you send the request to the correct agent by doing orchestration. I'm doing a maximum invocation count of 10, which means that my orchestration manager can forward a question for a maximum of 10 times to different agents to get the correct question answer from that. And then we have a group chat orchestrator, which is one of the many types of orchestration you can do. For example, there's parallel orchestration, which means you send your question to all of the agents simultaneously, and they all work together simultaneously answering your question. That is one way of doing orchestration. There's also orchestration in series, where you basically send your question to the first agent. It will do whatever it can that it's specialized in, and then when it provides an answer, it will give that answer and the original question to the second in line, and it can go through all of the different agents one by one, so not in parallel, but one after the other. But now I've decided to create a group chat orchestrator, which is basically a lot of agents that all sit together in the same group chat, and each orchestrator has its own speciality. And the agents that I've built are a general agent, where I can ask questions like, where is the Eiffel Tower? That is just a general LLM. I can use the power, solar, car, heating, smart lock agent, the sauna agent, and then I have something called photo carousel. Basically, I have like a painting kind of TV at the wall in my living room, and it just shows pictures from my holidays with me and my wife. So I can also ask questions about those photos, which is, again, a separate agent. And then inside of the manager class, there is a couple of functions here. I'm going to remove all of the extra windows so you can see. There's something called filter results, there's select next agent, and there is should terminate. And these three methods that you can override are basically the important part of this orchestration. Because what happens first? First, when you ask a question, it will actually trigger the should terminate function. So in the should terminate function, I decided to create an agent called the question agent. And the question agent, I will show it in just a minute. The only thing it needs to do is look at the question or look at the whole chat history, and it needs to tell me, is the question answered, yes or no? If the question is answered, then it should terminate. It should terminate the group chat because the question is answered. If the question is not answered, it should not terminate. So I have a specific agent that only does that. When you say no, it shouldn't terminate, the next thing that will happen is it will trigger your select next agent. And inside of the select next agent, I have my own orchestrator agent. And what this does is it adds a system message to the chat history that says, based on the conversation so far, which agent is best suited to respond next? The available agents are, and then a list of agents that I built dynamically based on the agents that are available. Reply with only one name of the most prominent agent. So if I ask a multiple question in one question, it will just look at the question, find the most prominent agent that it needs to answer that question, and it will return that. Then the orchestration manager from Semantic Kernel automatically will call that agent, it will answer that question, and it goes back to should terminate. If you have one single question and it's answered, the should terminate will say yes, and it will stop, and it will provide that answer to the user. If you have a question with multiple questions inside, then it will say no, not all questions have answered, and it goes back to select next agent, asking the same question. Like, what is the most prominent question in the history? Please answer it, correct agent. And this is what that 10 before meant. So 10 means that this can happen 10 times at most. So 10 times it will send your question again through this whole concept to select the best agent that can answer the question. And after 10 times, it will just stop because you don't want this to go on indefinitely. And then finally, when all of the answers are given, you have kind of a problem, because now you have a whole chat history with the original question, and then you have each agent answering separately, so you have all separate answers. So I've decided to create a reply agent, which is yet another agent, that just looks at all of those answers and just bundles them in one single answer that looks a little bit nicer. And then from this, we basically finish the whole idea. So if I ask a question like, what is the temperature in my car? And what photo is being displayed right now? That's a question that's basically two questions in one, and it's two different agents that need to answer this question. So fingers crossed. So now it tells me the temperature in the car is 26 degrees, so I guess it's in the sun. And the current photo being displayed is from Romania, taken in September 2023, because I had a road trip through Romania back then. So you can also see that two agents actually answered this question, because it says on top that the My Home car agent and the photo carousel agent have actually answered this question, which is pretty cool. So this is the idea of agents, where you have, if you have a very complex system that needs to be able to answer multiple kinds of questions, or you integrate with multiple applications or platforms, you can basically have multiple agents that are orchestrated to all work together, because that is what we human beings also do. When we are in a group chat and you're discussing a specific topic, each person has its own specialities, and then you have one guy that thinks he knows everything, right? But everyone is going to add his little thing to the conversation. That is basically what you are going to try to do with these agents, because when you make your agent to be specialized in something very specifically, the chance of it answering correct is going to be higher than if you try to put everything in one single agent. So that's why you want to build multiple of these agents and also have this agent-to-agent interaction. I'm running this all locally, so I'm just running this all inside of this application, all of these agents. So they're working together in this single application. You can use MCP servers, which I'm doing, by the way, to just do the tool calls, but the agents itself all live inside of this application. You can also build agents that live remotely. This is not part of my demo, unfortunately. That's a to-do on my end. But today you also have the agent-to-agent protocol, where you can basically put your single specialized agent somewhere online with remote access, and somebody else can integrate with that agent. So not only with tools, but with an entire agent, and then you can have multiple agents hosted on different locations work together in kind of an orchestrated way by using the agent-to-agent protocol, which is not part of this. So with that, I'm at the end of everything that I wanted to show you regarding Semantic Kernel. So everything except for MCP is part of Semantic Kernel. The orchestration is also part of Semantic Kernel. It does change quite rapidly, because Semantic Kernel is not in preview anymore, but parts of Semantic Kernel are. For example, these orchestration of agents is actually in preview. So the APIs, they will change over time, the coming weeks, the coming months, until they find something that they're really happy with. Because, yeah, this thing is just, it's growing, it's evolving rapidly. But I think it's pretty cool, and I'm already using this for questions that I get from customers to basically build chatbots in their applications that can answer in very specific ways, which I think Semantic Kernel is really, really helpful for. By the way, this is what I'm showing you now is all in code. You can basically do the same things in Azure AI Foundry also. You can build AI agents in Azure in a more visual way. You can build them in a more broad, like that they have access to specific documents and stuff like that. This is more specifically for code. And I think this is already quite powerful if you want to integrate something like this into your business logic. Of course, also be very mindful about how you integrate a large language model in your business logic. If you allow it through a tool function to have access to your database and do like delete operations, be very careful with that. Have something in between that can help you, so that the large language model doesn't by accident say, oh, call this delete whole database function because the user wants that. So be very careful, again. Also, don't try to feed important security-related information through parameters. I've seen people using these tools, functions, like with an argument, the token for the current user, so that when the user asks a question, that the token is sent to the large language model, and then the large language model will send that token as arguments to that function, because people can misuse that by asking for that token, by sending other tokens. I basically had the same in my quantum summer lab. Before I made the stupid mistake, which I fixed now. You've seen this before. I can ask clear chat history, which clears the chat history, which is just a function that does that, because I was too lazy to build a UI button for that, because I'm not good in UI. I decided just ask the Copilot and it will do it for you. But I could also ask clear chat history from, and then the name of another user. And it would just, okay, I cleared his chat history, which is not something that you want. So you really need to be mindful about that. Still keep your security intact and don't go through a large language model to avoid those kinds of misuses. All right, now I'm going to shut up. Very quickly go back to my slides. So this QR code brings you to all of the demos that I've shown you, and then that one single PowerPoint slide. If there's any questions, I'm here to answer them for you. Thank you. No questions? Yes?
So when that orchestration runs, there's a lot of calls back and forth.
Yes.
The LLM, were you using like a hosted LLM?
So in this demo, so your question is, like when you use orchestration, there's a lot of going back and forth with different agents. I've built all of these agents on top of my deployed GPT-4o. So they're all using GPT-4o, which in this case is fine, I guess. It doesn't really cost that much money for me for my demos. But of course, if you run an application like this for millions of users, that's going to get expensive quite quickly. I'm going to put the QR code back up in just a minute, but I wanted to show you. Do I have it still open? Well, basically here I did the same thing. If you can see it, in the bottom it says 179 tokens used. This is information that is not useful to the user. I just forgot to take it away. That is for me to know like how many tokens have you used. If you look at my, my other demo, again, very quickly going to show you. Where is it? Oh, this one. You can see that this gets more complicated quite quickly. Like, what is the temperature in my sauna? 1,400 tokens. But then, what is the temperature in my car and what photo is being displayed? 11,000 tokens. Because now there's a lot more orchestration going on. So you also need to be mindful of that. And indeed, you can specialize all of your agents. Maybe one agent is going to use GPT, whatever. Another agent is going to use some simpler, smaller model that is specialized in something very specific. So yeah, that's of course what you can do. Any more questions? No? Okay. Very quickly, because I forgot. If you look at the code for this my Copilot, all of these agents, you really need to describe correctly what they need to do. These are the instructions for my heating agent. Like, you should answer questions and receive commands regarding my heating installation, like, for example, getting the current temperature in my home, getting temperature outside, blah, 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 blah. Just use plain text, no markdown or other formatting. This is something very quickly that I did for my UI. My UI puts like the answer in different boxes. Maybe you've seen like these chat bubbles. Otherwise, it's going to be a very condensed block of a whole block of text, which I didn't really like. So I just asked it, could you separate each sentence with like BR, and I'm just doing a string.split on BR, and then put them in different chat boxes. It's a very stupid solution to a problem that didn't really exist, but it works. It works perfectly. So every sentence will have a BR in between, which I can use to split my string in .NET. Only answers questions and execute commands that are related to my heating installation, and don't ask follow-up questions. If you can only answer a part of a question, do so. This was very important for the orchestration part. Because a large language model, when it sees all of these questions combined, and it can only answer one of them, it will ask, are you sure you want all of these that I answer all of these, because I can only answer that. That's not what I want. It just needs to answer the one that it can answer and ignore the rest, because the orchestration will take care of all the rest. So you really need to fine-tune your instructions for each of these agents. All right. Again, if there's no questions, thank you so much. Enjoy the rest of your conference.